So my name's Mike Panaki. So I'm a guy that likes to capture packets, do analysis, take a look at things, get to try them out, and then do webinars like this and talk about how you can do that. So with that said, let's go ahead and frame up what it is we're talking about today. And that is eliminating the S word. And I use that a lot in a variety of different presentations I do. But our goal today is to eliminate the should about how much latency a device is adding out there to the network. So we're going to grab one of our little polls here, and I'm going to launch this first one. And it says, have you done latency tests before? So I'm going to throw that poll up there. I'm curious, how many of you have actually gone in and measured the latency of a device on your network to determine, is this the bottleneck? Is this really creating that slowdown on my network? So we're just taking a look at the number of respondents here, and I'm very happy to see that quite a few people have gone in and done these latency tests. In fact, we're going to leave this up for just a second if I see that the votes really slow down. So we're pretty close to 50-50, but most of you have done these latency tests. So I'm going to go ahead and say end the poll, and I'll share those results. So in this case, we've got 60% of the folks that responded have done some sort of latency testing on there, and 40% have not. Great. Well, for those of you that have done it, we'll see if this is something, a process that you've done before. And let's see, let me just go ahead and we're going to close that poll. And I've got one more out here. I don't want to crush you with polls, but I'm going to go ahead and launch this one real quick. And that is, how many of you have a Profi Shark? How many of you have an IOTA? And how many don't have either one of those? And so again, just give me an idea of what we've got. I'm going to type an answer here real quick. There we go. All right, so we'll let that poll run. And we'll come in. I'm going to go ahead and end that poll. Let me just share those results. So it looks like about 81% of the folks don't have either a Profi Shark or an IOTA. And that's okay. We're going to take a look at both of those today. We're going to focus on the Profi Shark, but we're going to take a look at the end of the presentation at what we can do with the IOTA. So let me go ahead and close that up. And here's the setup that we have today that we're going to use for measuring device latency. And that is that if I come in here and switch over to my little diagram right there, this is how I have things wired up in the lab. From the internet, we're going into a little Netgear GS105E Ethernet switch that has port mirroring turned on. That's going through a router. That then goes into another switch which has port mirroring turned on, and that goes to the device we're using to generate traffic. The Profi Shark is connected via USB 3 to my Mac that I'm using here for the presentation, and we're taking the traffic from the switch on the outside of the router, and we're taking the traffic from the switch on the inside of the router, and we're bringing that together inside the Profi Shark. We're merging that traffic with a timestamp resolution of about 8 nanoseconds, and then we're sending that off to the PC. So what this does is this gives us a way that we can go in and we can capture that traffic and we can bring it in together and take a look at what's going on. So I'll tell you what, let's switch over real quick here. And here we've got the setup actually right here on the bench. So here's the switch that is on the outside of the router. Here's the router, and here's the switch on the inside of the router. Now, if you've listened to me talk and in presentations before and beat on why tapping is so much better than spanning, you would say, Mike, why are you using two of these little Netgear switches with span? for what we're measuring today, these switches are going to work just fine. In fact, what I did, and we're going to take a look at the trace file because we like trace files. We're going to go ahead and take a look at a trace file where we eliminated the router and just ran a cable between these two switches so that we could get an idea of how much latency do we see added by the switches in here. Now, we can run the Profi Shark in inline mode. So in this case, if I came in and we've got our 2 ports right here, if we connected this up and we put this in inline mode, it would pass traffic through and it's fault tolerant. So in that case, if we lost power to this, it would continue to pass packets. Now, what this does is this is a hardware device that captures the packets and then sends those out a USB 3.0 port. Okay. Then we send that off to the PC to do the packet capture. Today, we have this set up in span mode. And in span mode, that means that I'm taking the traffic that comes in on each one of these ports, I'm merging that traffic together, and I'm sending out this port. This allows me to capture at full line rate, full duplex, gigabit without any packet loss. Now, we can also get the Profi Shark in a 10 gig flavor as well. For today's measurements, we're just going to be doing 1 gig because we're not looking at massive amounts of traffic for this one. What we're focusing on is capturing specific traffic. Let me put that back. Capturing specific traffic and taking a look at what the latency is of that traffic as it goes through there. Okay. So with that said, let me bring up the our first share here, and that is the Profi Shark Manager software. So I'm going to bring that up and I'm going to start my screen share here, and we're going to share that. And this is the application that I use to manage the Profi Shark. And in this case, I can come in and I can take a look at things like counters. So whether I have this connected to a span port coming off the switch, or I have it connected up to, in line, this is showing me information about the traffic that's passing through that device. So for instance, I could come in and let me come over here to my device that I'm using to generate the traffic. I'm going to run a speed test on that. So as that speed test is running, we can see that our packet counters are going up. Now in this case, we're tapped into a gig connection, and it's making it a little bit harder for us to see what, see the gauges move a whole lot, but it is giving us an idea of how much traffic that we have going through there, okay? Now, one of the questions is, doesn't the latency change under load on the router? And that is that's a really good question, because what I did was we're going to take a look at some trace files I captured. And I did do some trace files where I was doing a throughput test at the time that we were moving data through that router. And this is the question that we want to answer by doing latency tests like this. And that is, does it change? We can make a lot of assumptions about what's happening out there. We can assume that just because we think this is going to happen, it's actually going to happen. In this case, this allows us to come in and actually take these measurements. So what did I do for going in and measuring these? Now, the routers that I tested, and this is absolutely not a shootout of routers. Many of these routers have been sitting here in the lab for a decade, and they're old, and I really did want to choose some that had poor latency so we could go in and take a look at that. And this presentation is more about the method that we used for using the Profi Shark to measure that latency than going in and comparing these different routers. But let's go in here and take a look. And I just want to show you, if I go into my network ports on my Profi Shark, this is where I can come in and I can configure those ports. And here's where my span mode is. And with my span mode, that is where I went in and I said, I want to put this in span mode. So it's not in inline mode. Now, if it's in inline mode, it will fail to wire if I kill the power to it. And this is a really important part of this tester, is that if it loses power, it will continue to pass packets. And that's a very important thing when we're going and putting something like this in line. Today, we're not putting it in line. So you could either use a couple of little switches like we have set up in here, or you could set up a span port on the outside of your firewall and on the inside of your firewall and be able to pull that traffic together. The key is that we're pulling that traffic together with a very high degree of accuracy so that when we go in and look at our traces, we can be assured that that traffic is representative of what's really going across there. Now, in this case, when I ran my tests, what I did was I came in, I started a capture, I ran the same test each time, I captured the traffic, and then I went in and analyzed the traffic. So let's go in and take a look at a couple of things first off, okay? And let's go in and take a look at a couple things. So I'm going to change my share right here. I see the questions coming in, and I always like to make sure that, if there's anything really significant there, and not to diminish your question, Tim, but we'll go in and address that one. So let me come over here, bring up my trace files. All right, so this first trace file that we're going to take a look at is where all I did was put a cable between these two switches. I wanted to be able to measure what that latency was to give us an idea of, what are we looking at as far as the latency between these two switches if we don't have a router in there at all. So I'm going to come back and we are going to share that screen. I'm going to share Wireshark there, and I'm sure that there's some of you that were just waiting for this. So in this case, here we have our Wireshark trace. So what I'm going to do is I'm going to come in and I'm going to apply a filter real quick. Now this particular filter I'm applying, what we're doing is we're going in and we're applying a filter on the TCP SYN packets. Now, there's a lot of different packets we could look at. We could look at packets for round trip delay and so on. But what I'm interested here is just the TCP SYNs going through. So in this case, here we have our traffic. So I send this TCP SYN out to accounts.google.com. So what we do is we come in and we take a look at how long did it take that packet to get forwarded through this little switch setup we have. And that took 1.9 microseconds. Now, we're going to see that the serialization time of these packets will increase this time slightly because it takes a certain amount of time to serialize these packets onto the wire. But this gives us an idea of, was this a lot of time that we're adding by adding in this switch configuration, or is it a small amount of time? For the numbers that we're going to be looking at, this is a pretty small amount of time. So just in case somebody came back and said, hey, how much time is this whole setup adding? I did a test with just a straight through cable to take a look and see how much time that was. So with that said, let's go in here and we're going to grab a old Cisco RVS 4000 router, okay? Just a little desktop router. This is one that I've had sitting around. It was awfully dusty. I was actually surprised it came up and ran. I did have to reset the password on it because I had no idea what I'd set it to back then. But in this case, we're taking a look at that same traffic, but this time that traffic is being passed through this NAT router. Now, if we come in and we take a look at that, we come over here, we say, let's look at Google right here. Okay, so now, in this case, the traffic is coming into the inside connection of that router. So we're capturing it, And then we see it coming back out the outside. And if we look at the delta time between those frames, we see that that is 1.5 milliseconds. So here's the really important thing when it comes to going in and taking these measurements. The first thing we could say is, what's good? Well, I don't know. It depends on the equipment you're using and what your expectations of that equipment are. But what this does is by coming in and taking a measurement like this, it gives us a baseline that we can work off of. It gives us a way that we can come in and take a look at how much latency is this device adding definitively. For the last 25 years of my career, I've sat in numerous meetings where people will say, I feel like. And one that always gets me, and I tell this story, when my wife and I first started dating, we were standing in line in downtown Seattle for something, and there were a couple people behind me, and I could hear one person say, yeah, that email took like 3 hours to get through because the firewall held it. And, so they were saying that, hey, the firewall held this packet for 3 hours. And my wife, and we had just started dating, but she knew me enough that she looked at me and said, don't say anything. I said, what? She goes, it's killing you, isn't it? That they are saying that this is holding that for 3 hours. It's impossible. There's not enough buffer space in there to do it. So if it's not holding it for 3 hours and it's not doing it instantaneously, how long is it doing it? And that is why it's important that we can come in here and take measurements like this. So I can tell you that this particular device in here is holding that for about 1.5 milliseconds. Now, until we compare that with other devices, we don't know if that's good or bad. So as we come down through here, there's 1.538, there's 1.7. So we see here's 27. Well, no, scratch that. I clicked on the wrong spot. There's just under. So we could go through, but what this time is doing is it's giving us an idea of how long it's taking this router to go in and put that entry into that NAT table, establish that connection on the outside, and start that conversation. That's great. So now I have a little bit updated version of that router. And so let's go in and we're going to grab that trace file real quick. And I've got a whole bunch of these trace files, by the way. But in this case, here's a little bit updated version of that. So we see in this case, in this here we've got 626 milliseconds, 624. But we do have some that are close to a millisecond. So is that router that much better? I don't know. But what that does is it gives us a way we can start getting an idea of how do those two routers compare. Now let's look at one more here as far as these routers go. And we're going to grab the newest little MikroTik router. This is just a little travel router I carry with me when I used to travel. And in this case, what is this one showing? Well, here we see 121 milliseconds. That is an order of magnitude better than what we were seeing before. This router is close to 10 times faster when it comes to setting up that NAT table and forwarding that through than what we saw with those older routers. Well, I would hope so. It's newer. They've had an opportunity to develop better technology. But now I can measure that and say, is this router better than that router? How much latency is being allowed through? And if I'm measuring this on each side of a firewall, not only can I take a look at the latency, but I can go in and I can take a look at what packets are making it through, what's coming in on the outside, and what's making it through to the inside. If I have destination NAT set up, I can take a look at things like that. So being able to go in and capture on both sides. Our typical use for that ProfiShark is going to be putting that in line to capture with the device. This is a different way that we can approach that. Now, let me move a couple things around here. And so what we're going to do is we're going to take a look at another setup. A few of the folks that are on the call today have an IOTA. So where does the IOTA come into this? Well, first off, let me stop sharing my screen here. And we are going to switch over to a picture right here. And this picture is in the back room of my office here. And this is the IOTA. Now, what's the IOTA? The IOTA is think of a Profi Shark that allows us to do our full line rate capture with a 1 terabyte drive in it, plus a whole bunch of analysis software. So what's happening is we've got this 10 gig IOTA here connected to a booster. Now the booster is a 4 tap, or this has 4 inline taps that are aggregated to a 10 gig port. So we're taking 4 1 gig links, full duplex each, that'd give us 2 gig per link, and we're aggregating those 4 to a 10 gig port. So we're taking a potential of 8 gig and aggregating it to 10, so we're not going to oversubscribe that output port. I have this connected in the back room, and it's monitoring all the traffic going in and out of the studio here and in and out of my internet connection. Now, I'll tell you, the thing I was saying in the previous webcast I did on this, the thing I dislike about that booster the most is I wish I had more of them, because that tool, this one, I want to leave that connected in there all the time because I'm monitoring my internet traffic. But what I find is that being able to come in and monitor, use that here in the lab is very handy too. I could use that booster instead of these 2 little Ethernet switches that I've got connected up. So let's come over here. I'm going to minimize this, and we're going to come over and take a look at the IOTA. So let me share the screen on that. And I just want to show you that if we came in, and we're going to take a look at the last 5 minutes of traffic here, and let me remove my custom search filter. So here's my IOTA. It's showing all my traffic going across. I can see all that traffic going across there for the last 5 minutes. We could even come out and take a look. This has been running off and on. I've turned it off and on, but I could say, show me the traffic, for the last 12 hours. And it's going to show that traffic. There's where I did my webcast at 1 a.m. Pacific time for Europe this morning. So we can see that traffic going across. So we're capturing and writing it to disk. But to follow along with measuring the device latency here, what we've done in this case is we're tapping both the inside and the outside of my new router. I want to know how much latency that's adding because I bought a new router. I wanted to make sure it's going to be faster than the old one. So I'm going to come in and say, let's go in and let me move this cable over here. We're going to generate just a little bit of traffic. Okay, so now I'm going to get the IP address of the device I'm using to generate the traffic. That's 10.0.11.103. So what I'm going to do is I'm going to come up here and I'm going to say 10.0.11.103. We're going to apply that. Now this is going to show me everybody that device has been talking to for the last 12 hours. I don't care about the last 12 hours. How about the last 5 minutes? So now I could see what devices it's talking to inside and outside. Now there are some wickedly cool things that we could do here. But one of those, I'm just going to throw in here, is I'm going to say and not IP dest 10 star. Okay, so what I did is I just eliminated all of the local devices that I'm talking to, and I'm getting all of the outside devices. Okay, so now I've got this outside device right here. That device I have to pass through my NAT router to get to. So I'm going to say, you know what? Let's apply a filter on that device. And then let's remove our custom filter here. So now it shows me who's talking to it. So here's my inside device talking to it. And here's my outside of my router talking to it. So now I'm seeing both the inside and the outside. So what I'm going to do is I'm going to say, I want to download the traffic for that device right there. So I found the traffic I was interested in. I'm capturing on both the inside and outside. So now I can download that traffic. So we're going to open that, and we're going to come in here. And let me change my share. We're going to go back to Wireshark. All right. So here is my traffic. Let's see if I got this right. All right, right there. Here we see, let me move these windows right there. So if we come over here, here is a TCP SYN. Let's apply a filter on our TCP SYNs. Okay, so here I send a TCP SYN from my test device right here, and it goes to the MAC address of my router. My router then NATs that and sends it to the outside world. How long did it take to do that? 41 microseconds. So we started out looking at an old router that was adding 1.5 milliseconds of delay. We showed how we could use the ProfiShark to tap in on both sides of that router, capture that traffic going through there. Now we've come in and we're using the IOTA that we're capturing all the time, writing that to disk, analyzing that traffic. We're merging that traffic together with the booster. And in this case, we see that this new router that I bought is adding about 41 microseconds worth of latency. So we have numbers that we can compare. Now in the big picture, is this really going to slow down your traffic? No. But if this is something that you're interested in, if this is something you need to know, is this device part of the bottleneck that I'm seeing on my network, then this is where we can go in and use these tools to do that. This is another way to use these tools. It's like any tools that I have in my shop. There's not just one thing I can do with them. So whether you have an IOTA, and the IOTA could be connected to these two different Ethernet switches, and we could put it in span mode, do the same thing. We do it with the ProfiShark. But this ability to accurately merge this traffic together and then display it in a way that's useful to us shows us that. So one last one I'm going to show you here is I was curious, how much latency does a wireless link add? So I've got a couple of point-to-point wireless devices that I use. So I opened up the doors to my studio. I shot it through my garage, clear out to the street, about 200 feet. I wanted to see. So I ran an Ethernet cable out there. My neighbors are used to me doing stuff like that, I guess. But in this case, just to kind of wrap things up, here is a wireless bridge. And in this case, we can see how much latency going through those two point-to-point wireless devices adds. And in this case, I see that for this one, about 356 milliseconds. Now I'm going to show you a little trick with this one, and that is I've added this column in here, time since previous frame. Because we're not natting the traffic, time since previous frame in the TCP stream shows us that delay. And in the previous webinar, someone said, hey, is there an easy way to graph this out? If we're not natting, if we're just taking a look at the same packet twice, we can actually come in, and let me remove this column. I can go into TCP, and I can go into timestamps. I can say time since previous frame in this TCP stream. I could say make that a column. We're going to drag that column over here. We're going to crunch that down a little bit. Let's move it over one more. Now this tells, that timer right there is the time, how much delay that wireless bridge added. if I sort that, now I can sort that out, and I can see it added up to 5 milliseconds of delay. Now, again, great way to go in and measure these latencies and take a look at what's going on. So I'd like to thank you for joining on today. We could come over here and let me just take a look. So there was a question, is how long has ProfiTap been in this space? And they've been making taps for the last 20 years. This isn't new stuff, but what we are seeing is what's new and really exciting for a person that likes to capture packets is that it's going well beyond taps. We're seeing tools like the ProfiShark, where I can use that to augment my PC. I can allow my computer, my Mac in this case, to capture full line rate traffic and be able to have that fault tolerance to ensure that if I do lose power, PC shuts off, it doesn't go in and take that link down. Okay, so those are some of the things. Let's see. One of the questions was about why is it using the USB 3? Well, that's because that allows us to capture high rates and maintain the fidelity of those and maintain those high packet rates going into the PC. Okay. All right. And just as a note, these are all tested before they're sent out. Packets are run through them, and they're not just a white box solution that is coming out there. All right. So Richard has a great question. Do I have any other examples of how we could do this to troubleshoot traffic to improve network performance? Just as an example here, and let me stop sharing the screen. We don't need Wireshark anymore. Several months ago, I called my internet provider and I said, I'd like, what can I get for free? Because I found out if you call and you ask, they always have some promo going or something. Well, they offered to triple my internet, my download speed for no additional cost. So they said we tripled it. So I did a throughput test and I wasn't getting triple the speed. So what I did was I tapped in on each side and I saw that I was seeing packet loss. I was seeing delay on the part of my router, that the packets were coming in, but it was taking a while to get those acknowledgments back. TCP was backing off. I used the Stevens graph and Wireshark to graph out what that looked like, and I wasn't seeing the expected results. So I started making changes to the router. I started tweaking the settings in there as far as how it was forwarding the frames. And I was able to go in and use these tools to see that latency start going down, to see that more packets were being allowed through, and I could see a difference in the traffic rate that I was getting through. So as far as using this to troubleshoot problems, being able to come in and measure what's happening as you're making changes. If we can go in and measure that latency and we make a change, then we expect that latency to go down. And if it doesn't, I will typically back that change out because I don't know what other impacts that change may have. So using something like the ProfiShark, and there's all kinds of neat things we can do with it. If you have a Synology NAS, there's an app that you can load on that Synology NAS where you can plug the ProfiShark capture appliance into the network attached storage device, and it will capture those packets and write them to the disks in the NAS. This allows you to do long-term packet capture. So for a very small investment in a NAS, you can take the ProfiShark that you have and turn that into a capture to disk appliance. Now, if you want to go one step further, well, that's where tools like the IOTA come in. But it gives us a way to take a look. And Laurent made sure to mention that in the IOTA, we can take a look at round trip time in there, and we can start taking a look at what we've got, we can take a look at application latency. We can take a look at network latency. We can take a look at server retransmissions, client retransmissions, packet loss. So these are all things that we can go in and take measurements on to see what's happening in there as well. And this is taking a look at all the whatever traffic we want to look at. We've set up a filter on there. All right. Well, that was the focus of what we wanted to take a look at today. Please keep an eye out there. We're going to continue doing webcasts and showing you how to get the most out of these tools. They are not a single-use tool. There's a lot of different ways you can use it. I want to make sure that if you have one, you've got it in your backpack, you're taking it out and using it. The more you use it, the better you're going to get with it, and the more uses you're going to find for it. All right. Well, thank you. One of the questions always comes up, is the session being recorded? Yes, and you'll get a link out there to a recorded version of this session, so you could go back and you could watch it as many times as you want. All right, thank you very much. I hope you have a great day.